Lesson 8.2 is applying exponent properties now involving quotients. Before we have looked at properties of exponents involving products where we had those three properties, and now we're going to look at properties of exponents that involve quotients. Notice what happens when you divide powers with the same base. If I have a to the fifth power, that's really 5 factors of a. And a to the third power is 3 factors of a. And when you're dividing, if you have the same factors in numerator and denominator, you can go ahead and just cross them off. So that gives me a times a, which we learned from yesterday, is a to the second power. Well, if we make the connection between the 5 and the 3, this was really a to the 5 minus 3, which also gave us a to the second power. So I don't want to have to write out all this work. That's why it's nice if we can have this rule. So here, the quotient of powers property says let a be a non-zero real number, so a can't be 0. Let m and n be positive integers such that m is greater than n. If m is not greater than n, we would end up with a negative exponent, and we're not going to deal with negative exponents until the next lesson. So, to divide powers having the same base, we simply subtract the exponents. For example, 4 to the 7th divided by 4 to the 2nd is 4 to the 7 minus 2, which is 4 to the 5th. 8 to the 10th divided by 8 to the 4th is 8 to the 10 minus 4, which is 8 to the 6th. Negative 3 to the 9th divided by negative 3 to the 3rd is negative 3 to the 9 minus 3, or negative 3 to the 6th power. Here we're combining what we did the other day with quotients, or what we did with products, and now quotients. So I'll simplify the numerator. 5 to the 4th times 5 to the 8th is 5 to the 12th, divided by 5 to the 7th is 5 to the 5th power. 12 minus 7 is 5. Here I'm going to multiply 1 times x to the 6th is x to the 6th. My denominator is x to the 4th. X to the 6th divided by x to the 4th is x to the 6 minus 4, which is x to the 2nd power. So quotient of powers. Quotient means division, and we have our powers here. Next, we have a power of a quotient. Power of a quotient. So we have our quotient a over b to the 4th power. Well, that's 4 copies of a divided by b. So that's 4 factors of a, 4 factors of b, which turns out to be a to the 4th, b to the 4th. So it's essentially, again, we're taking this exponent to all factors in the numerator and in the denominator. And that's what it's showing us right here. B cannot be 0, because remember, you cannot have a denominator of 0. So b just can't be 0. So for example, if I have 3 halves to the power of 7, it's 3 to the 7th over 2 to the 7th. You take the 7 to all factors in the numerator and in the denominator. So let's do a couple of these examples. X divided by y to the 3rd is simply x to the 3rd over y to the 3rd. Negative 7 over x to the 2nd is negative 7 to the 2nd over x to the 2nd. Notice that I put the negative 7 in parentheses because originally that part of my quotient was in parentheses. And you may end up writing your final answer, because it doesn't say leave it as exponents. We'll write our final answer as 49 over x to the 2nd. Here I have 2 factors in my numerator, so it's 4 to the 3rd times x to the 2nd to the 3rd. And in my denominator, I have 2 factors. I have a 5, so 5 to the 3rd, and then a y to the 3rd. Now I need to simplify this. 4 to the 3rd is 4 times 4 times 4, so that's 64. X to the 2nd to the 3rd, I have the power of a power, So I multiply these, so that's x to the 6th. 5 to the 3rd is 5 times 5 times 5, which is 125, and I have a y to the 3rd. I can't do anything else to simplify this because I have x's in the numerator and y's in the denominator, and we can't just subtract the 6 and the 3 here. Here I have a to the 2nd divided by b to the 5th. So I have to go a to the 2nd to the 5th over b to the 5th, and then it's times 1 over 2a to the 2nd. This is going to give me a to the 2nd to the 5th is a to the 10th. I still have over b to the 5th times 1 over 2a to the 2nd. Now I'll take it down here, over here. I'm just going to multiply. A to the 10th times 1 is a to the 10th. B to the 5th times 2a squared, we're going to put it where the coefficient is first, and then we'll put it alphabetical. So 2a squared b to the 5th. This one's kind of long, but we're almost done. I have an a divided by, or an a to the 10th divided by a to the 2nd. So my a's are going to become 10 minus 2, so that's going to be a to the 8th from here, and then I still have a 2 and a b to the 5th in the denominator. If you take these a step at a time and don't try to rush through, I think you'll find that you have more success than trying to rush everything through. So step by step. Here's another one. The more examples you do, I think the better off you're going to be. So I have x squared divided by 4y. So this in the numerator becomes x squared to the power of 2. And in the denominator I have two factors, so it's 4 squared y squared. So there's step 1. Here I have a power to a power, so it's x to the 4th. 4 squared is 16 y to the 2nd. Nothing simplifies here because I have x's in the numerator and y's in the denominator. This problem here is going to be kind of long as well. I have 2 to the 3rd and s to the 3rd over 3 to the 3rd and t to the 3rd times t to the 5th over 16. I can take this out of parentheses since I don't have an exponent over here. Next, I'll simplify. 2 to the 3rd is 8, so I have 8s to the 3rd over 3 to the 3rd is 27 t to the 3rd times t to the 5th over 16. Now I'm going to go ahead and multiply. 8s to the 3rd t to the 5th is simply 8s to the 3rd t to the 5th. And 27 times 16, let's see what that is. 27 times 16 is 432 t to the 3rd. I need to go ahead and see if it's possible to simplify 8 over 432, and it is. I believe 8 is going to go into both of them, but I'm not 100% sure, so let's see. It does. 8 goes into 8 once, and it goes into 432 54 times. And then I have an s. I only have the s term in the numerator, so s to the 3rd. And then I have t to the 5th divided by t to the 3rd. 5 minus 3 is t to the 2nd. So this is your final answer. And for those of you that are wondering, no, you do not need the 1 up here. It's okay if you have it, but it's also okay if you do not have it. Okay, that is it for the notes. I'm going to go ahead and give you your assignment. Again, it's optional on whether or not you want to start it tonight or wait until Thursday when you actually get it in class. This is lesson 8.2, and it is page 498 to 501. problems 4 to 32 even, 33 to 46, and 56 to 60 even.